Hello everybody, welcome back to the stream. Today let's solve some lead code. So I have a few questions. Some question I just picked up. So this is the question I've selected. Maybe if possible we can do another one as well. But first let's complete this. So I hope the audio is clear. Hopefully. So then we can get started. Uh, Let me just have it like this. All right, so that I can see your live chat as well. All right, so let me just read out the question. Let's see. All right, so the question is find first and last position of element in a sorted array. All right. Um, Given an array of integers, nums, sorted in non-decreasing order, find the starting and ending position of a given target value. If target is not found in the array, return -1, -1 comma -1. Okay. You must write an algorithm with O of log n runtime complexity. So they're asking us to do it in O of log n time. Okay. Here there is nums given, an array nums are given, and then the target is 8. So in that case, it returns 3 and 4. All right. So how is that the case? Um, so this is sorted in non-decreasing order, which means it is ascending order. And find the starting and ending position of a given target value. Okay. So we have to find the starting and ending position of this target value. Okay. So here the first time 8 occurs is this is the 0th index 1, 2, and then third index. And the second time it occurs is in the fourth index, right? So third and fourth, right? 3 and 4 is returned. Um, in this case, target is 6. It is not in the array, so it's just going to return -1, comma -1. The target is 0, so anyway nothing is there in the array, so it is going to return -1, comma -1. Okay. So first, I think we have to handle these two edge cases, right? Um, After that, we can try to write the logic for this. Let's see. Let me just go to the whiteboard. Uh, so first, there are two edge cases. If target is not in array, then directly return this. Target is again in this case, if the array is empty also, then even then it is -1 comma -1, right? So let's try to write this. If you're just joining, welcome to the stream. Okay, so let's just start writing the logic. Before that, I'm just checking a few things. Just give me a few seconds. In the meantime, you can ask me if you have any questions in the live chat. All right. Okay, so let's just first handle these edge cases. First, if target, let me just call it as T. If T is not in the array, right? If T is not in the array, then if T, as you can see here, target 6, right? It is not in the array, right? So you can say this like if T, Ti is not present, in this, right? It's not present in, it's not equal to, right? So let me just can say not present, not present in the array, not present in the array which is uh nums, right? So can just say this is not in the array, right? Which is nums. So then directly I will just return -1 comma -1, and also the second condition is, first of all, there should be something in the array. If nums of I, maybe I can say dot is empty is empty, then I can probably just say, return, or maybe otherwise just see out the same thing here, right? -1 comma -1. Anyway, that was about the edge case, whatever it is. Um, let's write the logic. That is the most important part. So let's see how we can do the logic straight away. So they're asking to do it in off log n time. Um, so how can we get to this position first? First of all, the array is sorted in ascending order. Um, that is there. Um, uh, okay. Anyway, so if um, anyway, this is sorted, right? I think this array is sorted already. So if it is sorted, then um, okay, maybe I have to first check for first check for the occurrence of, I mean, the first time it is occurring, right? The first time it is occurring, and then the second time it occurs, I have to return that. Okay, so how about if I store the first occurrence? I have to anyway return the indices, right? Uh, okay, so uh, do I have to use a hash map for this? Okay. I'm just trying to think. Is it hash map? Let me just try to. I mean, first of all, let's try to think of the normal brute force solution, right? After that, maybe can optimize. So, brute force would be whenever I see target, whenever I see target, then return the index of that, right? And then whenever I see target again, then return the index. So, first, let me do that. Obviously, you have to do edge cases, but after that, we start with the for loop and I less than 0. And then I'm going to say target. Okay, not target. Um, I less than I equal to 0, right? I equal to 0. And then I less than nums dot size and I plus plus. Okay. Now here, uh, if I look at the current element, or I can have a condition here if the current element, which is nums of I, is equal to target, right? Then what should I do? This is a brute force. I don't think this is optimal, but let's try to solve it first. If nums of I equal to target, then I should uh, get the index, right? Um, I shouldn't get the element there. I should get the index of the element there. So, uh, how do I get that? Then maybe I'll just store that in a result array as well, probably, right? Uh, I mean, result vector here. So let me just create vector, another vector here, vector and then result. All right. Okay. I hope I've created a vector correctly. I mean, initialize the vector correctly, right? Let me just check it once. Mm, Declares the empty dynamic array named result that stores integers. Okay, so that is fine. So let me just, so then if this is the case, if the current element is equal to target, right? Then uh, what should we do? We should return, uh, we have to get, um, or we have to save this into the result, right? So let me just say result, uh, I mean, this is the first time it occurs, probably. We'll have to check it for the second time as well. Um, that is interesting. This will check the first time, but how would you check it for the second time when it reoccurs, right? So if you store this in a result equal to what can I say? Nums nums of I would just store this. I want the index, right? Uh, to refer to the index in C++. Let me just quickly refer something here. Right to the index index number. Okay, this is fine, but I don't want the element at the index, right? I want I don't want the element. I want the index number, the element, the index number at target, index number at target element is at. Okay, let's see. So container sorted or unsorted. Duplicates both methods above first and where target appears. If your data is completely sorted, then you can use std lower bound instead to find the index much faster. Or login, there is lower bound that we can use. Sorted in ascending. Lower bound, we can use this for binary search apparently. Okay, that's pretty good. Lower bound, You have duplicate numbers and you want the index of the last 40 upper bound instead and then subtract. That is greater than or equal to your target. This is what performs binary search. Lower bound numbers dot begin, numbers dot end, target. I think it is binary search, right? Let's try. Uh, this performs binary search apparently. Okay, let's see if you're able to get some fix. It's a binary search problem. Okay, so in that case, uh, we have to do this, I guess. Lower bound. Okay, that's good. Verify the iterator is valid and the element matches our target. Uh, it equal to target, right? That's all we need, I think. It equal to target. We can do that here, I think. For loops should still be there, I think. Um, Otherwise, how are you going to loop? That's the thing. Maybe not required, I'm not sure. Probably not required. Let's try. Subtract dot begin, calculate the index number. I'm sure there is a easier way to do this, I think. There's a better way to do this, right? For sure. Let me just bring back the for loop here. And all right. Okay, so there is something suffixed. Use binary search to find the iterator. Okay, that is fine. Check if the target was actually found. Convert the iterator directly to the index number. Okay, store the index number in your result iterator. Okay, let's first try to do this, right? And then later we can do other stuff. It not equal to nums.end. I think this checks if it is not there. Yeah. So let me just try to add that here. So let me add it here. If uh, it, that's what is here, right? It not equal to nums.end and also this, right? All right. Okay. Then what do you have to do? Then if that is the case, convert the iterator directly to the index number. Int index. Okay. What is this distance? What is distance? Uh, int index distance nums dot begin. What is distance? I think it is already. Um, okay. Distance probably finds the index, right? Okay, anyway, let's just do it here. Distance. Let's see. Calculate the index of an element in a vector. Okay. Library function that counts the number of steps needed to go from the first iterator to the second iterator. Okay. Result dot pushback store the index number in your result vector. All right. So if that is not there, if it is not there, then store the index in your result vector. I mean, if it is there, of course, not this. Uh, result dot pushback, right? Result dot pushback index, and that is good enough. And after that, return result here. I think you can return result. There is an extra, I think, yeah, it can return result over here. result. Let's see. For now, this is what is we have done. Let's run and see what happens. There is some error. What have we expected? Okay, there is a syntax issue. Numbers. Okay, it is nums, it's not numbers. Nums, let me change that. Nums, okay. That is done. Alright. Now let's see. Okay. At least we are getting an output. Of course, it is not correct, but see. Okay, the target is 8. Output we are getting 3, which is the first time it is occurring, but we also need the second time it is occurring. So that is also there. Case 2 is not handled as well, which is the edge case. Okay, at least we get partially correct output. So let me just handle this edge case first. So if um here if what can I say, if IT not um that is iterator, right? Uh else, maybe after this else as well, can just put it as else here, maybe. How about this else can't have two returns, I think. Else return -1 comma -1. I don't think you can do this, but let's just try what happens. Let's just see what happens. Okay. Um, should I just do it here? Vector int, vector int empty equal to -1 comma -1, and then return empty. How about that? Okay, I think the syntax we got it wrong this time. Okay, all right. Should be good, I think. Okay, we have handled the edge cases now. But then this is an issue, right? Um, how can we get the second time it is occurring? We have to get the second time it is occurring as well. How can we do that? Um, let's read this here once again. So iterator checks, right? if nums dot end, this goes up till nums dot end, and it equal to target, then int index equal to distance nums dot begin comma it. Let me actually try to understand this. Nums dot begin returns an integer. It returns an iterator pointing to the very first element of the container. All right. Represents the current iterator pointing to a specific element inside the container. So this is the current iterator, right? Uh, okay, this is the current iterator. This is the nums dot begin is the first element. Distance, what does it do? Counts the number of steps needed to go from the first iterator to the second iterator. All right. Ah, okay. That makes sense, right? That makes sense. So that is good. Now what we want is when it occurs again, when it occurs again, how can we find that? Um, do we add an else if, uh, okay, else if I think is not bad here. Result dot pushback index. Instead of this, uh, or I can add an and also here, maybe. Once I've done this, this goes to index, all right. I'm not returning result here. I'm only pushing index here. So I think I can also do an else if here, right? I can probably do an else if here because I'm not returning anything here. So what if I do else if again the same thing? Else if it equal to target again, and this probably has to be the same, right? Just repeat the same code, right? Uh, but what if like 8 is like somewhere later, like in the 10th index or something? How can you know where it is exactly? That is the question. It's if, what does this do? Um, okay. So let me just say nums dot end, nums dot end minus, maybe minus, that won't do it, right? I'm not sure. Nums dot end minus, let me just see what happens here. Nums dot end And okay. So if that is the thing, then let's take this. This happens again. Um, nouns dot begin, not from begin. We don't want to begin, I think. Or maybe we do want from begin. Anyway, else return empty, that is fine. Let's just close it here. That's all right. And then result push back again. Let's just see what this does. Result push back index. This is for sure. We have to push back again, but then I'm not sure about this part. But anyway, let's try. What comes here? Okay. Some issue. Result. Okay. Dot pushback. Okay. I have to do like this. Syntax again. What happens now? Let's see. Uh, Still outputs 3 only. Okay. Hmm. I mean, obviously, we are doing the same thing again. Something has to change, right? So let's see. What if we don't need this? But obviously, I think we do need, but let's try without it. Goes to a runtime error, goes to a runtime error. All right. So that is obviously not what we should be doing. Uh, Distance. I think this is what we should change, right? Or maybe the condition, obviously. The condition is probably what we should change. Because this is obvious, I mean, this is going to calculate the distance, which is the index. This is not going to change. I think the condition is what is going to change. So let's see. Else if, let's see. Okay, here. I want to know the second, second occurrence of target as well. Your current else if condition will never run because it uses the exact same condition. Okay, that is what I did. Anyway, let me just put it here. Guide me, guide me without giving the exact solution. Okay, now let's try. This is the else if structure because you need both the first and the last index. You shouldn't use an else if. An else if structure forces the program to pick either the first one or the second one. You wanted to find the first one, store it, and then move on to finding the second one. Meet upper bound. Upper bound searches for the first element that is strictly greater than your target. Plus one behavior because upper bound looks for the first number strictly greater than your target. The iterator will point exactly one step past your target's final occurrence. How can you mathematically adjust the index you get from upper bound so that it points back to that final 8? Lower bound will point to the first 8, upper bound will point to, okay. So what should we change here? This. Check if lower bound actually found your target right at the beginning. If it didn't find it, or the vector is empty, can return it empty immediately. If it didn't find it, you are 100% guaranteed that the target exists, and you can safely run upper bound logic right below it without needing any complex nesting. Alright, so we need to have upper bound as well. Okay, so upper bound. Okay, let me just change this. Okay, that is somewhat what I should do. First underscore, okay, last iterator. Now I'll have to change everything, but that's okay. This is for first. Here it is going to be first. Is this good enough? Last. Maybe let's try this. What happened here? Undeclared and fire. Okay, I have to change here as well. So first and then last. Let's see what happens now. Now again it gives me 4. I need 3, 4, but it still gives me only 3. Okay, anyway, somewhat closer though to the solution. Rename variables as done directly after lower bound. Check if the element was actually found. If it was not found, return empty right away. Okay. If it was found, use distance to find the first index to push it to your result vector. Calculating the second is what we want, right? Once you know the element exists, you can safely use upper bound iterator, which we named last it. So we should probably check if the element exists first, then that's all right. Let's do this first then. If Does this check the element exists? If after this is got to be else, or else if whatever. Uh, if okay, return empty. All right. Now let's see. Norms dot end. This shouldn't be norms dot end is not what should be there, right? I think it should be target norms dot end. Okay. First, let me just have this as target. I think. Now let's see. Uh, the second index it's begin comma last. Okay. Subtract one from that number, so it points back to your actual target element. That adjusted index to your result vector. Okay. Okay, then we probably have to we put this as index 2, right? And then yeah, that is better, I think. Here I'll just have this as index 2 and then index 2 equal to index 2 minus 1 and then just return index 2, push back index 2. Maybe that is good. Now let's see if it is fixed. Maybe run and see first what happens. Okay, there is an error, but anyway, let's just put it here. Uh, First iterator, this is the issue. Okay, anyway. Okay, just two errors to be fixed and it is done. First array is an iterator. Yeah, it is. A target is a regular integer. You cannot compare them indirectly. To check if target was missing, you need to verify if first it reached the very end of the vector, or if the value is pointing to first it is not equal to the target. Okay. Plain else cannot have condition inside parentheses. Okay, that is fine. That can be fixed. Else if. But this is where we have to change things a bit. So here it's probably still nums.end. Um, okay. Then maybe we can say first it is not in target, right? Is that good enough? Let's try. Okay, again it is not. Let me just put an and here. Forgot the and. Now let's try. Okay, something. Uh, Still we're not getting this. Now the case 3 is also gone. Let me see. This is fixed. This is fixed, I think. Let's see if this is fixed actually. To check if the target was missing, you need to verify if first is reached the very end of the vector or if the value is pointing to is not equal to your target. Okay, this is done. Okay, and also condition here. If your if statement correctly catches. Okay. I think we need to learn iterators better because otherwise it's difficult to retrieve indexes. Change your first if statement. Okay. This is or, I think. It's not and. Remove the else keywords. Any code below it only runs if target definitely exists. You can now remove the else if chains completely so that both index calculation run one after the other. So looks like we don't need the else if. We just need the if condition to check this. Just need an or here and then we don't need else ifs. Like, okay. All right. Then we don't need all this. Because anyway, that is for checking only. All right. Okay, now this is good, I think. This should be good, at least now. Return result, what happened here? Hmm, what should I do now? This is not required, I think. Think that is it. Alright, let me just run it again. Runtime error. What happened? What happened here? Was it a runtime error? Okay, here, okay, alright. This is equal to right, that's what we need to check. Because has to go up till the last. Oh, finally it's accepted. Let's submit and see what happens. Hopefully it's submitted. Yeah, finally it is accepted. I think we need to do more of these kind of problems uh, where we have to get the indexes. Otherwise, we can't practice this, especially the iterators, right? So, yeah, that's it for today. We're just able to solve this one problem. But anyway, that is okay. Uh, if you have any questions, you can ask me. Else, I will just end the live stream here. Okay, all right. I think there are no questions. I'll just end it here. All right. So, yeah, I think I'll just end it here then. So, that was the solution for this question today. All right. And it's accepted. So, yeah, um, it's a medium level problem. So it's all right if you take some time, but try to do it by yourself. So, yeah, um, so that's it for today. Um, hope you enjoyed watching this live stream, and if you did, please do consider subscribing to the channel and also share it with your friends who might also like it. And yeah, meet you in the next live stream. Until then, see you and